All right, guys, so we took a look at various examples of Laplace transforms for various functions that are very common. We also want to see how operations get transformed under these Laplace transforms. There are multiple types of operational transforms that we're going to concentrate on. In particular, we're going to take a look at multiplication by a constant, addition and subtraction, uh, differentiation, which is one of the key ones, integration, translation in time, translation in frequency, and then scale changing. I'm going to go through the proof of at least a few of these. However, for the remainder of the ones, the proofs are either in the book or you can actually take a look at them in tables. So the next topic is the topic of operational transforms. The first one that we're actually going to take a look at is multiplication by a constant. And I'm going to let the constant itself be. Doesn't matter if it's positive, doesn't matter if it's negative. Right? Now, suppose we assume that the Laplace transform, oops, I'm missing an S. The Laplace transform of f of t is by definition f of s, like this, right? Then what I want to do is I want to consider, well, what is the Laplace transform if I had taken constant k and I had multiplied by f of t, right? So what I'm doing is I'm taking f of t and I'm essentially scaling it, and I can scale it up or down, right? Now, this question is relatively simple, right? We can actually go back to these definitions. So by definition, if the Laplace transform of f of t is f of s, well, remember what that actually means, right? It is the integral from 0 to infinity of e to the minus st times f of t dt, like this, right? So if I actually have kf of t, then the Laplace transform of kf of t is by definition the integral from 0 to infinity of e to the minus st, not times f of t, but times kf of t, like this. It's a constant. This, by assumption, is constant, which means we can pull it out of the integral. Right, so this is the same thing. Let's do this not in red, let's do this in black. As k, the integral from 0 to infinity of e s to the t times f of t dt, like this. And you should be able to recognize that that's the original Laplace transform of f of t. So this is the same thing as k times the Laplace transform of f of t, which was f of s. So here, the conclusion, this is actually a relatively large one, is that the Laplace transform of kf of t is equal to k of s. And this is what we actually wanted to get to. Now, it doesn't seem like a very big thing, at least at the moment, but what this tells us is if we happen to have a function whose Laplace transform we know, right, then I can take that function, I can multiply by a constant, right, take the Laplace transform, and it will be the Laplace transform of the known function times that constant again, right? And you'll see how this actually gets used in a practical sense as we start taking a look at more stuff. But let's take a look at more operational transforms.